Series and sequences. Time to get serious. I know that's pretty bad, but who cares, right? Alright, so lesson 1, Introduction to Series and Sequences. We'll be going over some notation and definitions in this first lesson. We will do some work as well, so a few questions on, just really basic series and sequences. Very general stuff. But everything you learn in this lesson is really important. Because obviously, if you don't know the language, if you don't know the terminology, then you won't understand the hard stuff. You need to know your basics, obviously. Alright, so what is a sequence? A collection of numbers in a defined order following a certain rule is called a sequence. Each of the numbers in a sequence is called a term of the sequence. So in simple English, that just means a sequence is a set of numbers which are arranged in order. They follow some sort of pattern and they are written in order. So if you just wrote something like 1, 3, 2, 21, 5, 89, 7, that's not a sequence, right? The condition is it has to have a logical order. There needs to be a logical sequence such that you can figure out the next term, right? There has to be some sort of rule, some sort of pattern. For example, if I said to you 1, 3, 5, 7, and you can see I'm saying the odd numbers, right? It's very easy to see it's a sequence because you can figure out the next number. It's going to be 9. 1, 3, 5, 7, 9. Similarly, if I said to you the squared numbers, for example, 1, 4, 9, we can kind of see, it's probably the sequence is probably the numbers which are squared numbers, and the next number is going to be 16. So it has to be a sequence is a set of numbers which are arranged in order. It's a set of numbers. They follow a certain rule, right? And I guess the main criteria you can think of, just in simple English, everyday language, is you need to be able to predict the next number. And that's probably the best way to think about it. And set of numbers, and they're arranged in order. Alright, so moving on. An example is the Fibonacci sequence. You may or may not have come across this before. The Fibonacci sequence is as follows: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. And it's just, if you're interested, you can pause the video now and try to figure out the pattern. If you can't be bothered, don't worry, I will explain it in a second anyway. But yeah, it is an interesting one. I first came across it when I was in year 3, and it is very, very popular, very famous. So we call the numbers in a sequence its terms. So that is a term, that is a term, that is a term. They're all terms, right? This is the first term, this is the second term, that is the third term. So the Fibonacci sequence's first term is 1, second term is 1 as well, third term is 2, and so on and so forth. And how does that actually work? Well, 1 and 1 are the first two terms, and every term thereafter is basically a sum of the previous two terms. So to get the third term, we just add the previous two terms. 1 plus 1 is 2. And to get the next term, the fourth term, we look at the last two numbers and we add them together. 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 5 is 13. And so on and so forth. So the third term is 1 plus 1 is 2. The fourth term is 3. Fifth term is 5, kind of like what I just explained, and so on. It keeps happening. To get the next term after this, you just add 55 and 89. So the Fibonacci sequence is a set of numbers, and they are arranged in order. And remember our criteria, we can predict the next term. There is a pattern, and that's why it's a sequence. Alright, another example is a sequence of square numbers: 1, 4, 9, 16, 25, and so on. And the first term is 1, the second term is 4, the third term is 9. And, we can actually draw something like this. Just so that... just give me a second. Okay, so let's say we did something like this. Alright. I'm drawing a table, right? The first term, the second term is 4, the third term is 9, the fourth term is 16, and so on. And the idea I'm trying to explain to you is that the position of the term in the sequence, okay, this is the first number, this is the second number, that's the third number, that's the fourth number. The position is related directly to the value of the term. It's just n squared, right? So let's say that is n, in other words, the position of the term in the sequence, and that is the sequence, right? 1, first term is just 1 squared, 2 squared, 3 squared is 9, 4 squared is 16, and so on. So if we let t of n denote the nth term, term n, right? Then the sequence can be written algebraically as the nth term is simply n squared. So the 9th term will be 9 squared. The 100th term will be 100 squared. The second term is 2 squared, right? The second term is 2 squared, which is 4. And I guess we're just writing this algebraically. Now the value of a term is directly related to the position of that term in the sequence, which is what I just explained, right? Depending on what term you want, the value of that term will depend on the position of the term. First number is 1 squared. 10th number is 10 squared, and so on. And this will apply to all sequences. Okay, so just a quick revision. Please try and answer these yourself before you give these a go. And I guess all I'm really saying is, what does t of n mean? Pause the video, give it a go yourself. Okay, t of n, and the answer is the nth term. So t of 3, the third term, would refer to the third term. t3 is the third term. What is n? Again, pause, check your, try to give it a go yourself, revise. If you need to go back in the video, go back in the video. We really need to check our own understanding rather than, watch the video mindlessly. Please try and be active while you're watching this. So pause the video, give the questions a go yourself first, and then see the answer. Alright, so n is the position of the term in the sequence. So, in the sequence below, where that is the sequence, 2, 5, 11, 14, right? What is n? Well, n refers to the position of the term. What's the position of 8? 3, so n is equal to 3. T of what? Well, that's the third term, t of n. T of 3, t of 3. What is the third term? The third term is 8, so t of 3 is equal to 8. Okay, moving on. Third example. Look at a very simple sequence. 1, 3, 5, 7. That's a sequence of odd numbers. And algebraically it's 2n minus 1. For example, if I substituted in... I'll just enable the pen. If I substituted in the first term, right? The first term, I'm going to substitute 1 into that equation. So 2 times 1 minus 1 is equal to 1. 2 minus 1 is equal to 1. That's why it's 1 there. If I substituted number 2 in, the second term, remember n means position of the term. We want the second term. So 2 times 2 minus 1. Well, that's 2 times 2 is 4, minus 1 is 3, and that's why it's, you see, 1, 3, and it'll just keep on going. 1, 3, 5, 7, so on and so forth. Oh, there's a link. Alright, let's keep going. Now we've incorporated the algebraic rule inside the brackets above. Let's look at the sequence in a table so we can explore the relationship between the terms and their position in the sequence. 1 is 1, 2 is 3, 3 is 5, 4 is 7, and so on. And if you substitute n in that equation, and you substitute n into the equation, you'll get the value of t of n. So the 100th term, you would substitute in 100. 2 times 100 minus 1. Very easy. The value of each term is related to the position of that term in the sequence. The rule that is being followed is double the position and subtract 1, which is just this algebraic rule in words, I guess. I guess the main idea I'm trying to get across is you have position, and position of a term inside a sequence will determine the value of that term. Now, what is the difference between sequences and series? I mean, this topic is called series and sequences, right? As you can see here, series and sequences. So, what's the difference between a series and a sequence? Well, we already know what sequences are, we just did it. A series is basically if you add all the terms of the sequences together. That's all it is. So, series is a sum of the terms in a sequence. We normally refer to the infinite sum, so you just add up all of the terms till infinity. But if you only wanted a certain number of them, we'd call it a partial sum of the series. That's just a technical definition, nothing to worry about. I'll give an example and hopefully it'll help. Okay, so 1, 4, 9, 16, so on and so forth, the sequence of squared numbers, that is a sequence. You have a bunch of numbers, the dot 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 refer means that they go on to infinity, okay? Now, to make this a series, we just take out the comma, put a plus in. If you added all of these terms together, it would just be a series, okay? So you have a sequence, and a series just adding up all the numbers together. And a partial sum of the series is you get only some of the numbers, the first 5 numbers, the first 6 numbers, the first 100 numbers, and you add them together. That's a partial sum of the series. Alright, so sigma notation, it gets really tiresome having to write. It gets really tiresome having to write all of these numbers. So I guess mathematicians got sick of it, so they came up with a shortcut, right? And this is the way it works. This sign, what it means is the sum of. And it won't be by itself, obviously it'll be the sum of what? Like, the sum of what? So you will have an algebraic expression just to the right of this. That'll be the formula for the nth term. And below it, you'll have n is equal to, and generally that letter over here will be the same as the letter that they're using in the algebraic expression. So if that was k squared, over here it would be k. And I think the next door neighbor's dog is barking. Just close the window. Hopefully we can't hear the dog anymore. Alright, so the variable will be substituting. And the idea is, let's say we want the sum of a certain first 5 numbers, first 5 square numbers, right? So we will be substituting in n is equal to something into there 5 times. And we'll see how it works in a second, okay? So we will be substituting n. Where will we start? What will we start substituting with? Do we start substituting at 1 squared or 10 squared or 50 squared? Like, where do we start? And A will tell you where to start. Generally, it will be 1 in general. Start subbing in 1. And then we'll substitute in 2. So, okay, so you'll substitute in A, right? A squared. Then you do plus A plus 1 squared. And where do we stop? It's K. Okay, and if you're not quite sure, don't worry. When you see the example, I think it'll make a lot more sense. It's very logical, very easy. So the last term we sub in is K. And total number of terms is K minus A plus 1. And I'll explain this in a second. Alright, so let's see. Let's say this was the series that we want to write in shortcut form. Now, what that is the first term, the second term, the third term, and so on. How would we write this? The sum of squared numbers. The sum of squared numbers. We started by substituting in 1. And we kept on adding. Like, we substituted in 1. And then we substituted in 2 to get 4. Then we substituted in 3 to get 9. We're adding all of these, remember? And where do we stop? Infinity. There's no stopping point. Sometimes you will have a stopping point. And we'll get to that in a second. Okay, so we read this as the summation of n squared from n is equal to 1 to infinity. You start from here, keep on going. Now let's do it in reverse. And for example, if this was the notation, this is what it said. The summation of n squared from n is equal to 1 to 7. How would we do this? We substitute in 1 into n squared. You get 1 squared plus. And this works like a counter. We just this number changes, goes up. Becomes a 2 now. We substitute 2 into n squared. 2 squared plus 3 squared. And where do we stop subbing in? At 7. So we're going to keep on subbing in until we reach 7. So 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. And then we stop. Because our limit, the last number we sub in was 7. And if you wanted to know, let's say if it was in n is equal to 1 to like 99, how many numbers are we going to be substituting in? Well, that's where this formula comes in. Total number of terms is equal to K minus A plus 1. So the high number minus the low number plus 1. So for example, 1 to 7. 7 minus 1 is 6. Plus 1 is 7. So let's check. We have 7 terms. 1, 2, 3, 4, 5, 6, 7. Yes, we've got 7 terms. And it looks easy now, but sometimes it'll be like, from n is equal to 5 to n is equal to 59. And it can get a little confusing. It's not simply, 7 minus 1 is equal to 6. It's not 6 terms. You gotta add the 1 at the end. Alright, so finally we're gonna reach some of the questions. So a term in a certain sequence is given by the algebraic equation 153 minus 4n. Okay, so that equation gives us a certain term in a sequence. Find the first 5 terms of this sequence. Well, what we're going to do, if I can get my pen working. Alright, so for the first term, right, we're going to substitute it. Let's just try all of them. Let's sub in each one by one. 153 minus 4 times 1. And clearly we can see that's 149. Alright, second term, we're going to substitute in 2 into that equation there. So we'll have 153 minus 4 times 2, right? And that is equal to, well, that's 8. And that's just going to be 4 less than this, so 145. Right, and let's do as well. And remember, sorry, this is really messy, but it's hard to write on a computer, So 153 minus 4 times 3, and that's 12. And it's just going to be 4 less than that, so 141. And we can see a clear pattern here. It's going down by 4, isn't it? So we don't really need to... Remember, a sequence has a pattern, and we've figured out the pattern, so I don't even need to substitute in anymore. I can simply write it down. 3, 140, 137 will be the 4th term, and the 5th term will be 133, I think. Alright, and let's just check the answer. I'll wipe off everything, erase the whole income slide. 133 was there, so it's going down by 4, right? Now what is the sum of the first 5 terms? Just add all of these together. 149 plus 145, blah blah blah. And calculator, easy. In notation, we'd write it like this: from n is equal to 1, 10 is equal to 5. You substitute 1 by 1, and the answer will be 705. What is the 64th term of the above sequence? What's sub in 64? Right? Since t of n is equal to 153 minus 4n, and we want the 64th term, t of 64th term is equal to 153 minus 4, and we sub in 64. See, n was 64. We substituted in 64 here. We're going to substitute 64 into the n value over there as well. So 153 minus 4 times 64. Put in the calculator and we get negative 103. And which term of the sequence is 45? Well, it's just algebra, really. We know that we want the answer of 45. Remember, this formula gives us a certain term. We know the term this time. We know it's 45. So we sub it in and we need to solve for n. It's just an algebraic equation. Solving just the algebra. There's nothing fancy about it. It's a really simple algebraic equation. Solve that and you get n is equal to 27. So 45 is the 27th term. And what is the first negative term of the sequence? And by the way, these questions that I've chosen, more or less they represent almost all of the questions that they can possibly ask in the HSC. Okay, so if you can do these questions, if you can understand these questions, it will really help you do, like, I'd say 90 to 95% of all of the questions for this topic. Okay, so there are a few of them, but they will really help you to do all of them. So what are we doing? What is the first negative term of the sequence? Well, we want the nth term, whatever it is, to be less than 0. So let's just solve for that. 153 negative 4n less than 0. That's just an inequality. Solve it, you get n is more than 38.25. And again, it's just simple algebra. You should know how to do this inequality. N is more than 38.25, therefore n will be 39. Because the first integer value after 38.25 is 39. Alright, question 2. The nth term of sequence is given by 2 times 3 to the power of n minus 3. Now the question is the number 1482 part of the sequence? And if not, find the first term of the sequence greater than 1482. And it looks scary, it's really not. We're just going to use whatever we've learned to we're just going to apply it into this. Now, that gives us a certain value. We're saying, is 1482 part of this sequence? Well, you just sub in stuff, just, guess and check, really. You could solve using logs, but I'm just going to assume for the time being that you haven't done logs yet. When you've done logs, this is really easy. You solve for that. Very easy. But let's just use guess and check. It's a valid way of solving this question. Mainly because in a sequence, the numbers follow a pattern. So if you can write down n is equal to 1, n is equal to 2, like we just substitute 1, 2, 3, and so on, and we write down the answers, we can see a pattern. We will know if 1482 is part of this sequence or not. For example, if the pattern goes something like 1, 5, 9, 16, we know clearly 13 is not part of the pattern. There's no reason for the numbers to come back down. Alright, and if you just try it, you'll see. So please do pause the video, give it a go, and you'll see for yourself. Just guess and check, right? Question 3 is evaluate that. Well, we're going to sub in r is equal to 1 to the whole equation plus r is equal to 2. We sub it in, and we do plus, and then we sub in r is equal to 3. And we just add all the terms. Easy. Let's look at the answers. So, if 1482 belongs to the sequence, then the nth term is equal to 1482 for some positive integer value of n. N cannot be a decimal or a fraction because the position of a number, position of a term, right, in a sequence, it has to be an integer value. You can have the first number in a sequence and the second number in a sequence, but it makes no sense to have the 2.5th number of a sequence. It doesn't make sense. It'll just be the third number, right? It's either the second number or it's the third number. There's no in between. So n has to be a whole number. So when we were guessing and checking here, right, we only need to sub in 1, 2, 3, 4, 5, 6, 7, 8, 9. And if it's not, if the answer is not 1482 when we sub in a whole number, then we know it's not part of the sequence, right? So that, divide both sides by 2, 3 to the n minus 3, 7, 4, 1. You can use logs to solve it, but just using guess and check. 3 to the 5 is 243, 3 to 6, 729, which is slightly less than 1741. 3 to the 7, remember 6, 7. 5, 6, 7. We're substituting in for n. N has to be a whole number. 3 to the 7 is 2187. Clearly, we cannot get an answer of 741, right, using whole numbers only. So therefore, it's not part of the sequence. That's really it. Very easy. Alright, now using the values above, it's easy that the first term of the sequence is greater than 1482 has to be 4374, which is the 10th term. Again, just use guess and check, and you'll see it. Question 3, subbing in the 3 terms and adding gives us an answer of 1. Just sub it in into that algebraic equation, and that's really all it is. So the homework is Coronius chapter 9a. The worksheet will be on the website or on Slack. You'll find it either way. Alright, best of luck.